So page 16, the special part about this one is we have square root in the questions, okay? So of course, if we just try to sub in right now, right? For example, if you look at 17, okay, 17, the top has x to the cube, right? Inside, like in the denominator, you have x to the 6 and square root. So when we sub it in, you will get infinite, okay? If it's just substitution, right? Sub x as infinite, then you will get infinite over infinite, right? Both top and bottom, you get super big, okay? Even though there's a square root, right? But then it's x to the 6, so still very big, right? The bigger the x, the bigger the result, right? So this is also indeterminate because you don't know which one. So let's see how we can deal with those. So at the top, we have 4 examples here. So it's not just just limited to these ones because question can change. So, but I hope from these 4, right, in future you see other question that you haven't seen before, you can do the similar analysis, right? And then you can draw your own conclusion, right? So the first one, I think we went over, we've seen it a couple times before. So here I want to explain how each of the following can be simplified into absolute value function. And once you get to absolute value function, you have to think about piecewise function, right? How to take away absolute value. So the first one over here, square root of x squared is the same as absolute value of x, right? Okay, because any number, if I sub into the left side, right, it will get square first. So it will make it positive and then break it down, right? Bring it down back to, for example, let's say I plug in, okay, I'll plug in -2 square and square root. Then that will give you 4 square root and that will give you 2, right? And then same thing here. If I plug in -2, it will also give you 2, right? So both of them, both sides do the same thing, giving you a positive value. So because it's absolute value, so if I want to break it down, if I want to take limits, we have to discuss 2 scenarios. So therefore, square root of x squared can become piecewise. Okay, one is it will stay the same, right? The other one is times negative, right? So this one is nothing new. It's just like before. So what's the domain for the x? Jeffy? X must be
Greater than the root x squared.
No. Greater than the root of x squared like this?
Yes, I think so.
No. Think about absolute value. You have two rules for the 2 pieces, right?
Mm-hmm.
One, it will stay the same. Okay, because square root of x squared will be absolute value of x. First, whatever inside will stay the same if the inside is what kind of number? If I plug it in, it won't change. Can you give me any number?
0.
Okay, if I plug in 0, what does it equal?
0.
So it won't change, right? Make sense?
Mm-hmm.
Okay, what other number, if I plug it in, it won't change?
Oh, wait. No, okay. I'm just really tired. I wasn't thinking. I think it's just x is greater than 0.
Can it equal to 0?
Yes,
Yeah.
x is greater or equal to 0.
Yeah,
My
so
bad.
it will take the first path if whatever inside is greater or equal to 0.
Yeah.
Right? You've seen this before, right?
I'm just very tired.
I know. Okay, what did you do today?
I had an interview, but then I woke up I woke up pretty late today, so then I'm also very tired from that.
Is that for a job interview or school interview?
Just for school.
Okay. All right. So second piece. How about Lex? What's the second piece? Domain.
X is less than 0.
Yeah. Okay. So this part is nothing new. Okay. Just help you guys get warmed up first. Okay. We can box that. All right. And let's look at what happens with the second scenario. Okay. So we have x to the 6 and then square root that. What does that equal, Jesse?
I got absolute value of x cubed.
You think this will be an absolute value as well?
Yes.
Yeah. Okay. Let's try. Right. See if it also works like absolute value. Right. So if I input a negative, right, to the left side. So let's say if I input -2 to the 6, right, and then root that, what will be the final answer that comes out, Carrie?
So it would be 8.
It will be 8. Yeah?
Yes. Yeah.
Okay. Right? Okay, you can try, right? -2 times -2 times -2, right? 6 times. And then that will be 64, right? 64, and then you square root that, that will be 8. Okay? Now if I do the same thing on the right hand side, -2 cube absolute value, right? So it will inside will become -8, but then because of absolute value, it will give you 8. Okay, so it works just like absolute value. Okay, so this is how you can analyze if you are given a question you never seen, right? They can give you infinite. So for example, they can say 4 through and then x to the 8, right? If the question has this, right, you need to know how you can change it, right? Whether it's like absolute value. Let's erase that. Okay, so because it's absolute value, therefore again we can write it as piecewise. Okay, so we're equal to 2 pieces. One piece is the, okay, let's also write it out, right? Because it can equal to x cubed absolute value. So one piece will stay the same. So it'll be x cubed, right? When what? What will be the domain, Joan?
When x is greater or equal to 0.
Okay, you're pretty close. In fact, it will be x cubed greater or equal to 0.
Oh, yeah.
Right? Remember, you have to take whatever inside and make it greater than 0. And then if you keep root, right, it will stay the same. So at the end, okay, then you are correct, right? So it will be same as x greater or equal to 0. So anything positive, it will stay the same, okay? And then the other one will be the negative, right? Just like before. And then x less than 0. Okay, so that's our second scenario. Okay, let's look at third one. Okay, third one is a little bit different, right? Now we have a cube root, okay? Inside is x cubed. So what do you think will happen here? I cube it and then cube root. How do we simplify this? Nicole, what do you think?
To capital, which makes sense, right?
Do you have to
Okay.
put it into a fraction?
Fraction? What do you mean fraction?
I don't know.
Simplify. For example, the previous two, right? I can simplify into absolute value of x cubed, absolute value of x, right? What about this?
Okay. Like you sub in the -2 and then it becomes
I do.
negative
Yeah, I
8.
did before.
And then
How many? Yeah, I stopped. Yeah, that was my side hustle for the longest time.
yeah, I'm not sure. Sorry.
Okay. Carrie, what do you think?
it's like the first one, so like A, except it's cubed. So I
Okay.
think it's just like absolute value of x, but maybe a negative on the outside. I'm not sure.
Okay. Maybe a negative on the outside. Okay, we'll try, right? You need to learn how to test it out, right? Test out your hypothesis, right? See if it works. So the question A, we checked that they equal by subbing in a negative, right? See if it becomes positive. If it does become positive, that means it works the same as absolute value, right? The square root canceled out, but then you need to add the absolute value. So let's see if also works here. So subbing in value is for you to test out, see if your simplification is correct or not. Okay, so let's say I plug in, okay, -2 cube and then cube root. Okay, so Nicole, you were saying, right? You were subbing in the number. Can you tell me what you get on the inside?
Method,
Um,
they have two.
sorry, can you repeat
two
that?
different
The cube root of what value?
solid
8
bars that can
or
lead to
negative 8.
the electrolyte
Okay, can
solution.
we take cube root of -8?
And
Okay.
total the 4 parts, right? 2 electrodes and 2
Wait, sorry, can you
electrolytes.
repeat that?
Can we take cube root of -8?
Yeah,
I,
they're
yes.
What do you get?
You
they
get
should-
negative
for the
2.
diagrams.
Yeah, okay. So for cube root, it's possible to have a negative answer, right? And also negative on the inside. It's okay, right? Cube root. Now let's try the right-hand side. We also sub in negative, right? And I put absolute value, and I put negative, right? Then it will equal to, the absolute value will make it positive, right? Okay, Emily is here. Let me get her in. Okay, so it will become +2 and then times the negative. So it will become that, right? Become -2. Emily?
Hi, I'm sorry I'm late. Sorry.
Okay, we are on the next page, okay? Right, so right now it seems like it works, right? Left and right side works. Now let's see if it also works if it's positive.
Oh yeah.
You see?
Yeah, I was just about to ask, but if you leave the negative, then it makes every single number negative.
Okay, yeah, so that's because the absolute value has to work for any number, right? We want to make sure the positive works, also the negative number works, also the 0 works, right? You want to check everything left side and right side works. So right now the negative works, right? Now if I make it positive, I sub in positive.
Jason,
Yeah, Carrie?
would it just be x?
Would it just be X?
Yeah.
Okay, yeah, so we'll get there. Okay, let's see if this one works or not. Okay, so if I put in 2, that will make it +8, and that will be 2, right? Now if I do the same thing on the right side, will be 2, right? On the inside, absolute value is still 2, but then there's negative, that will make it negative. So these two won't equal. Okay, so that's how you figure out, okay, this time the cube root with the x cube, it does not become absolute value. Okay, so instead, right, like Carrie added in, she said, okay, it could be just x. It just cancels out. Okay, so for example, if I sub in 2, it'll be 2, right? If I sub in -2, it will be -2. So left and right side will equal. So simply just x. You don't need absolute value. So this one, you do not have piecewise. Okay, so if the question has cube root and cube, right, you can test it out, okay? See if you need absolute value or not. So the point here is to learn whether the simplifying needs piecewise or not. Okay, the first two, it needs to become piecewise. C, you don't, okay? So let's write a conclusion here. But of course, these are just examples. Right? You need to learn how to test, right? See if it's equal. So this is just equal to x. Okay, so this is our conclusion, right? So question D, I would like you to try to do the testing by yourself, okay? And then you let me know what kind of result you get here, right? Would it equal to absolute value, or would it or it doesn't need absolute value, okay? So after you get a conclusion, please raise your hand, okay? And I'll help Emily to catch up. And Emily, do you have any question like about C?
I'm just writing down the notes. Give me a second.
Okay, I'll let you finish writing the notes and then I can quickly go over, okay?
Okay.
So now your job for D is to think about, does it become something with absolute value or we don't need absolute value, okay? Like C, right? Does anyone need me to clarify these things? Okay, a little bit confusing, a lot of thinking involved. Okay, Leon, Nicole, any questions? Okay, Leon, what do you think?
It does not need absolute.
So what do you think it equals?
Just x squared.
X squared, okay. Anyone else? How about Joan? What do you think?
I got the same thing, just x squared.
No absolute value,
Mm-hmm.
okay. Lex?
Yeah, x squared.
Okay, no absolute value. Yep, okay, yeah, it's correct, okay. So I think everyone gets it. Emily, what about you?
I'm good.
Do you understand A and B?
I think so.
Okay, it's just showing that if both sides, right, if the left side works the same as absolute value, you need to add absolute value on. Okay,
Okay.
and then question C, if you add absolute value, then both sides they don't equal. So question C you don't, right? And question
Okay.
D is kind of like having absolute value, but it's not needed, right? Because if I sub in -2 to the 4, which is 16, square root will be 4, right? And that is the same as subbing in -2 squared, which is also 4, right? So I don't need absolute value, even though the answer comes out positive all the time, okay? But square works like absolute value, right? If I input +2, still get 4, right? +2 still +4, okay? So I don't need absolute value. So for this one, will equal to simply x squared,
Okay.
okay?
Mm-hmm.
So that's the point of knowing these things. So if you see the following questions, these ones, they have square root and then x to the 6, right? So that's why you need to think about, does it become absolute value or not, okay? And then if it does, then you will need to, if it becomes absolute value, then you need to turn it into piecewise, all right? So because this question 17 is a fraction, right? So we have to borrow the idea from the previous question, right? Last class. We need to multiply top and bottom by 1 over x to the p. And p is the degree of denominator. Okay, we are still using that for anything that is rational. Except this time the rational has square root inside. Okay, so what's the degree of denominator for this one? Jeffy?
Degree 6.
So it looks like it's 6, right? But since there's a square root, we need
So
to cut in half.
So just be 3.
Yeah, okay, so the maximum, right? Because x to the 6 and it's square rooted, it actually end up with x cubed. So we have degree of 3 in the denominator. So therefore, we need to multiply this time because it has square roots. Hold on, let me move this thing over first. Okay. Move it to the, it doesn't move. Oh, yeah. Okay. So we need to multiply top and bottom by square root of x to the 6. Okay, like this. Right? Top and bottom we need to multiply by the same thing. Okay. The reason why we choose x to the 6 square root instead of just x cubed, because only square root can multiply with a square root, right? Inside times inside. For example, if I have x to the 3 times x to the 2, square root 3 times square root 2, right? Then it can multiply, right? But if it's like square root 3 times 5, it can only stay outside, right?
Jason?
To 5 root 3. Yeah, Jesse?
Can we multiply by like 1 over x cubed over
Yeah.
1 over root x to the 6?
No, it has to be the same.
Oh, okay.
Yeah, okay. I'll explain very soon, okay? So right now we choose root x to 6 because it needs to multiply with the denominator, okay? And then for the top, we need to make it go away later, okay? So let's do the denominator first, okay? Denominator is the easier part. Right? So because the denominator, they both have square root. So I'm simply just gonna draw a big square root, and then each of the term on the inside will divided by x to the 6. Just like last week, okay? All of them will be divided by x to the 6. So the first term will be just 25, right? X to the 6 cancel out. Plus x to the 4 over x to the 6, so that will cancel out as well. We'll give you x squared, right? 1 over x squared plus 2 over x to the 6. Anyone has question about this step, how we get here?
Yep. I don't get, because wait, I just don't get how we went from 25x to, like, I see how it's supposed to work, but how does that look if we write it out?
Okay, so let me show one more step because I kind of skipped, right, to see if you can sort of do that in the head. So I'm gonna write it more slowly, okay? Just pull it on the side, right? So here, right? So what happened in the denominator is, you can think of it, it started with that. Right, you have square root and then times it by root x to the 6. Do you follow so far?
Yeah.
Right, because this, yeah, so the red part, right, is in the denominator, and then
Yeah.
this is the numerator. So pretend you don't see the numerator right now, right?
Okay.
And then because they both carry square root, so I can write it together. So it'll be 25x6 plus x to the 4 plus 2 over x to the 6. Agree?
Yeah.
And then you just split up the fraction.
Okay. Okay. Yeah, I see it.
Yeah. Okay. So each term divided by the same denominator.
Yeah. Okay.
Yeah.
Thank you.
Oh, yeah. No problem. So it will get this part. Okay. So of course, in the future, right, you don't have that much time to write this out, right? The step on the side. So it goes straight to the what I did on the left side. Okay. So now for the numerator. The numerator, the question does not have square root. So I need to simplify the right-hand side. But then now we have square root of x to the 6. How do we simplify square root of x to the 6? Jeffy, how do we simplify that one?
All right, which part?
This part. The square root of x to the 6 for the numerator.
For the numerator, right? So you just put the 10x cubed, that top part, and then you divide it by root x to the 6.
Okay. My question is just the root x to the 6. Can we simplify that first?
You can simplify it to root 1 over x absolute value to the power 3.
X. So.
Sorry, x to the 3 absolute value.
So 1 over x to the 3 absolute value.
Yeah.
Agree? Okay, so Jesse, this one, the top, we need absolute value, right, Jesse?
Yeah.
Okay, so it doesn't just become x to the 3. So the reason why the top we need to simplify is because the question doesn't have square root. So they don't belong to each other. You got to simplify it before they can multiply. Okay, they don't look alike. But then denominator, they both have square roots. So I don't need to simplify into absolute value.
Okay, but the top you have to.
Yeah, okay. The denominator, you can just start dividing.
Okay.
All right. So now that brings us back to piecewise now, right? Because the point of turning into absolute value is so that we can write piecewise. So therefore, we need to think about the two p's. One is x cubed, one is negative x cubed. X greater or equal to 0, x less than 0. This one is the one, which one is it? Yeah, the one, part B, right? Over here, the one I put start on, right? We went over that. Let's put a star here too, okay? So now we need to decide which piece does this one turn it into. Let me erase the sub in, okay? So we have more space. So what do you think? Which piece does this absolute value turn to? Does it become x cubed? I get x cubed.
Wait, it's x cubed, right? Because the infinity is positive?
Yeah, very good. Okay, so you think about what kind of x we need to use, right? You look at the domain. Oops. Okay, the domain here, because all the x, okay, we are using a positive infinity because of the question. Okay, so you look at the question, the little thing here, this part. The question wants us to make x goes to positive infinity. That means the x value will be very big, positive. So it will become x cubed. So here, right, we can write it as 1 over x cubed. Which means if the question has negative infinity, then you need to add a little negative, okay, as you take away the absolute value, okay? So now we have decided to use this one. And we do the same thing, okay? Each of the term on the top divided by x cubed. So it'll be 10 minus, okay, what will be the next term? Carrie?
3 over x.
Yep, very good. And Joan, what about the next one?
8 over x cubed.
Very good. Okay, 8 over x cubed. Okay, because in the answer key, they don't explain like this, okay? Then you get so confusing. Sometimes you get negative, sometimes you don't negative. In fact, there's so much things happening behind the scene, right? Behind the scene. Yeah, so this one it's really easy, right? But if you just look at answer key, you will think, oh, square root of x6 just become x cubed. But it depends on the infinity, positive infinity or negative infinity, okay? So this one is how you deal with square roots, okay? So now things gets easy from here, right? The ones that has an x in the bottom will go to 0, right? These are all 0 because denominator gets bigger, right? Go to 0. So you're just simply left with 10 over root 25, okay? You don't need to put plus minus at front, okay? Because the question doesn't have plus minus. So 10 over 5, which is 2. Okay? So which means the next question you have to do it, right? The next question has negative infinity. So let you try it out and see how that would affect the answer, okay? So when you finish, please raise your hand. And if you have any questions about A, you can also ask me now, okay?
Mr.
Yeah.
Jason.
Yes, chicken.
The question, wait, for this one, it's negative infinity, but that only changes the top, right? It doesn't have anything to do with the bottom.
Yeah, the positive negative infinity only matters when you try to take away absolute value.
Oh, okay. I understand.
Yeah.
Thank you.
You're welcome.
Was wholesome Japanese
What? Any question, Lex, Leon, Nicole?
Oh, I'm just still doing it.
Okay, no worries. So it's still multiply the same thing. Okay, Lex, what's your answer?
I still have 2, but
Also
I don't know if it's right.
2, positive 2 here. Yep. Okay, Joan, how about you?
I got -2.
-2. Okay. Emily?
I also have -2.
-2. Nicole, how are you doing? Still working on it?
And the
Oh, I
following
forgot
week
to put
will
my
be
hand
Indian
up.
appreciation. So
What do you have, Nicole?
but
Um,
on the
I
Wednesday,
got
the
-2.
Wednesday is the
All right, so let's go over that, okay? So for the numerator, right, denominator is the easy part. For the numerator, it will turn it into absolute value of x cubed. And because the limit is approaching negative infinity, then it should equal to 1 over what, Leon?
Can you repeat the question?
Right now, right, do you see the fraction I'm writing? 1 over, right?
Yeah.
Okay, what should go underneath? 1 over what?
X to the 3.
Is that it? Just 1
Yeah.
over 3. So this is the part that you need to pay attention now, okay? Because the question has negative infinity. Do you see where I put the star?
Yeah.
Okay, then that means all the x will become negative. So you have to choose, right? Look at the bottom left corner, choose the negative piece, x less than 0. Got it?
Oh, okay.
So therefore, the absolute value will take the second path and it becomes negative x cubed. Understand?
Oh, yeah.
Okay, so when it becomes absolute value, do not just take it away right away, right? Think about, is it taking the first path or the second path, right? You have 2 pieces. If there's no absolute value, then nothing to worry about. You just start dividing, right? So after that, we distribute in, right? So each of them divide by negative x cubed. So that will make it -10 plus 3 over x minus 8 over x cubed. So you see the sign changed. Now denominator will be same as before because they both have square root, right? Nothing to worry about, right? No sign change. 25 plus 1 over x squared, just like before. Okay, and then we make things goes to 0, goes to 0, goes to 0. So you're left with -10 over 5. So answer is -2. Okay. Any questions so far? So these two is like the standard question, okay? So hopefully on test they give you something simple like this, okay? If you call these two simple, but if they are being mean, right? They can mix things up, okay? For example, like question C, numerator, right, has square root, also has no square root, right? The 2x. The denominator has no square root. Okay, so you just need to worry about sign changing if you have no square root, right? Because you need to take away the square roots. Okay, so I would like you to try question C by I'm modifying. Okay, I want to modify the question. So please change this into negative infinity. Okay, so I'll let you try it out. And yeah, and if you finish, you can raise your hand. Okay, this one you need to think about which parts needs to change sign, which part doesn't need to change sign. Okay. Okay, let me just check how to start. Okay, I want to know what you multiply with first. So Joan, what do you multiply for top and bottom?
I'm still kind of thinking about it, but I kind of have an answer. I don't know. I was kind of confused, but I put for the bottom 1 over x,
Mm-hmm.
and then for the top, like for now, I just put 1 over square root of x squared, but I'm still trying to like figure that out.
Okay, you was the initial step. You should always start with the same thing, right? Root
Okay.
x squared for top and bottom, and then you just think about which one you need to change into absolute value or not.
Okay.
Okay, so top and bottom should always start with the same thing. Then, and then you simplify whenever needed. Okay.
Okay, thanks.
Like question A, right? Question A, we only need to simplify the top, right? Because the top has no square root. The bottom, you just keep it. Right?
Wait, Mr. Jason,
Yeah, Jesse.
are you allowed to have like a whole number plus the square root over another number?
Yeah, yeah.
Oh, that's legal?
It's a number, right?
Oh, okay. Okay.
And then you cannot add them up, right? It will just stay as.
Yeah. Yeah. Okay. I think okay, thank you.
What's your answer look like?
Wait, okay, I got 2 minus root 2 over 5.
Oh, over 5?
Yeah.
Okay.
So I had that, but like I was trying to figure out if I did something wrong because I didn't know if like that's legal.
Possible. Yeah, it's possible.
Okay. Mercy.
Yep. Anyone else? Raise your hand if you finished. Okay, Emily, what answer do you have?
I'm probably wrong. I
Yeah.
have root 2 over -5.
Root 2 over -5, like that?
Yeah.
Okay, all right. All right, Carrie, it's always good to try, right? Okay, Carrie, what's yours?
Well, I have a different answer too.
Mm-hmm.
So I got root 2 plus
Mm-hmm.
2 over -5.
Plus 2 over -5, like this?
Yeah.
Okay.
Yeah.
Yeah. Okay, so we got some overlapping, right? So we have -5, right? And then everybody has root 2. Okay. Let's get one more, okay? One more answer. See if we can have a match. Okay, Jeffy, what's yours? Do you match any of them?
I also got root 2 plus 2 over -5.
Okay, okay. Right, so maybe we should go over, okay? See how to write it out, okay? Step by step. So this one is a bit confusing, right? As we want to distribute, let's start with the denominator, okay? Denominator, because it doesn't have square roots, so we need to simplify, okay? So this part, it will first become 1 over what? Lex, what does this part equal? 1 over?
I did 1 over negative x
1
because
over negative
it's
x.
negative infinity.
Okay, yeah. So we'll start with the absolute value, okay? Because I'm showing step by step, and this absolute value will become negative x. Okay, it's a piecewise. Now for the top, okay, let's finish the bottom first. So if we multiply it in, each of the term in the denominator divided by negative x, so it will give you -5 plus 1 over x. Any questions so far, anybody? Okay, now for the numerator, it's a bit tricky now, okay? If you multiply with the square root, you don't need to simplify. Okay, so that part I can do it first. So be square root each of the term inside divided by x squared. So that will give you 2 plus what, John?
Plus 1 over x squared.
Yeah, okay. If it already has square root, I don't need to worry about it. I just divide inside with the inside. Now for the outside, right? If I want to multiply with the 2x, I need to simplify it. So I need to turn it into absolute value one more time, right? And because it's it's a negative infinity, so it becomes negative x. Okay, so if you are multiplying with the 2x, you need to use negative x. That's why this one is a bit confusing, right? Part of it needs to simplify, part of it doesn't. So that will make it minus now instead. -2. Agree? Anyone wants to ask question how we get any of the parts? Okay, because after this it's like a breeze, right? Everything just goes to 0, right? This goes to 0, goes to 0. Okay, so you're left with what, Leon?
Root 2 minus 2 over negative 5.
Yeah, over -5. And this, if you like, you can move the negative to the top, will be negative root 2 plus 2 over 5, right? Either answer works, okay? So let's see if we have any match. If you have negative at the bottom, the top, you should have minus, right? So this one doesn't, right? This one, one term, right? We're missing the 2 part, okay? So this one is okay. Okay, any question? This one is tough, okay? But I do see one, and remember one of the students showed it to me, right? How to do this question. Usually the homework will be like question A or B, okay? You don't need to do different thing for different terms. Okay, let's do another one, okay? Question D. So question D, after you finish, also please raise your hand. D should be easier. Okay, it doesn't have different things. Okay, so this one is also negative infinity. Okay.
Wait, Jason.
Yes, Jeffy.
If it's not absolute value, does the negative infinity have any effect?
No. No.
Okay.
It doesn't do anything. Yeah.
Okay. Just making sure.
Yeah, because if it doesn't have absolute value, then
there's
it
no piece
just stay
left.
one piece, right? Yeah. There's no two pieces. Yeah.
Okay.
So it doesn't matter what x is; it's always the same function.
Sounds good.
Please raise your hand if you finished. Okay, Jeffy, what's your answer?
I got 1.
1, okay. Nicole, what's yours?
I got 1.
Also 1, okay. Joan?
I also got 1.
Okay, looks like everybody wants to be number 1. Okay, so what do we multiply top and bottom with? Emily?
1 over root x to the power of 4.
Yeah, so 1 over root x to the 4. Okay. Now, Leon, which side, like numerator, denominator, which one needs to be simplified?
The denominator.
Okay, what do we simplify this into?
1 over absolute x squared.
Absolute value of x squared like this?
Yeah.
Okay, why do you think we need absolute value here?
Oh, and then I changed it to 1 over x squared.
Well, this one, okay, if you remember on the top, right? It belongs to A, B, C, D, which one?
A?
A, well, A has x squared and then square root.
B.
B has x to the 6.
D.
Yes, D, okay? So if you look at D, what does it equal?
X squared.
Yeah, so it doesn't go to absolute value at all, okay? There's no absolute value at all, right? So it doesn't go to absolute value and then become x squared. It's just straight to x squared, okay? So that's how you pick. So this one will be x squared. And then we multiply then, it will be lim negative infinity, right? So it'll be 1 plus 2 over x squared. The top, you just inside divide by inside, right? And then we just bring things to 0. You're left with 1. All right, so that's all the rationals, right? That has square roots, okay? So all of these are indeterminate, okay? Because if you sub in infinity, you get infinity over infinity for every single one. Now, if you look at question E, it doesn't have fraction, okay? So if we try to sub in absolute value, right? For example, first one, it will be infinity, right? Infinity plus 1 is still infinity. Square root is still infinity. So you get infinity minus infinity. Now, if they are the same, it could equal to 0, right? But if the first one is way bigger, then you will get infinity, right? But then if the second one is way bigger, you'll get negative infinity. So you got 3 possibility. So that's why it's called indeterminate, okay? So this is indeterminate. So let's put it here. We have several forms of indeterminate. Later we'll put a conclusion, okay? Write out all the forms we've seen so far. So for this one, because it has square roots, so we're gonna try to turn this into either one of A, B, C, D, right? To make it look like a fraction first. Okay, and then we can do the same thing. So how can we rewrite it so it can become a fraction? Any suggestion here? What can we do?
Can we do? Oh, never mind.
Hmm?
No, I thought it said negative.
I want to multiply something.
Conjugate?
Conjugate, yes. Okay. What will be the conjugate of this one?
Root x plus 1 plus root x.
Yeah, root x plus 1 plus, right? A minus will pair with a plus. And then I cannot just multiply by that, right? I have to multiply top and bottom. So it's like multiplying by 1. So it doesn't change the question. So the left side, right, the question will like having an invisible 1 in the denominator. So this thing is called the conjugate. Okay, let me box that. Okay, multiply conjugate. Okay, and the reason why I think of that is because we want to have a fraction. Okay, and then we can do the same thing as we did in ABCD. So once we have a conjugate to multiply, the denominator is the same, right? What does the numerator now becomes, Jeffy?
You multiply the. Oh wait, are you asking me for what, like the answer?
The numerator, how do we simplify the two conjugates?
Just be x plus 1 minus x.
Yes, x plus 1 minus x. Can I simplify that?
Yes. To
Into
just
what? Hmm?
just 1.
Just 1. Okay, so let's cross that out. Okay, so now if I try to take the limit again, what do you think it equals?
0?
0, right? So this one, it doesn't create any absolute value stuff, right? You don't have the x squared and square root, those complicated things, right? So even though the question has square roots, right, it become a simple thing. So this one just 1 over infinity, right, which is 0. Okay, so last question, I would like you to try it by yourself. Okay, it's kind of similar, right? You don't have, if you just sub in right now, right, you get infinity over, minus infinity. So that's also indeterminate. Okay. So in question E, right, in question E, we end up with the first case where they are the same. So that's why it becomes 0, right? At the beginning, we predict, right, the 3 scenario. So it's the first one. Okay, so if you finish question F, please raise your hand. Once we finish F, we'll have a break, okay? Please raise your hand if you finished. Anyone has trouble?
Yeah.
Okay. Which part? How far do you get to?
Oh, just multiplying the conjugate.
Okay, can you tell me what you have after you multiply the conjugate?
No, I don't. I'm trying to figure out how to multiply the conjugate.
Okay. Can you tell me what you have right now so I can write it down?
Oh, okay. I have a square root of x squared plus 1 minus x,
Mm-hmm.
and then multiplied by square root of x squared plus 1 plus x
Mm-hmm.
over the same thing.
Yeah. Okay. So far, so good. Do you have anything else after that?
Oh, 1 in the denominator. Yeah, that's it.
Okay. Now for the denominator, if you multiply, what do you get?
The just 1 times that.
So we
X squared plus 1 plus x.
Yeah. Now for the top, you have to use the difference of square, the formula, the special product. Do you know what I'm talking about?
I think so.
Right. What's the formula?
A squared
Mm-hmm.
plus b squared, right?
No, a squared minus b squared
Oh, minus b squared.
equals a plus.
A plus b and a minus b.
Yes. Okay. Do you see the a minus b and a plus b on the numerator?
Mm-hmm.
Yeah. So you use the formula. Do you get what I mean? Which one is the a?
X squared plus 1 rooted.
Yeah. Okay. So this is a minus b, and then the right hand side is a plus b. Do you see it?
Oh, okay.
Yeah. And then you use the formula, and it will become two terms. So let me know when you get get an expression for the top. Okay. I'll wait for you. Emily, what's your final answer?
I have 0 again.
0 again. Okay. Lex, John, do you have questions?
I think I'm good. I don't know if I did it properly, but I also got 0.
Okay. So Leon, do you have the numerator now?
Oh, just 1.
Yep, just 1, right? The x squared canceled out, right?
Yeah.
Yeah, okay. Now what do you do? Leon, what do you do now?
Okay, I was just writing. Then you plug in infinite.
Yeah, okay. And because only the denominator has variable, right? So only the denominator blows up. So which makes the whole thing goes to 0. Okay, so this is how you would show work, right? If you if you want to show step how you get a 0, right? And then otherwise you can only, like, if you just plug it in, you just get infinity minus infinity, and then you cannot say that's 0. All right, so if you don't have question about everything here, then we have a break. Okay, right now it's 15, perfect timing. Okay, so we'll start again at 6:30. Okay, I'll see you after the break.
Thank you.
You're welcome.